Okay, so let us start. So, somebody asked this question. So in this course, we have been seeing the detailed mathematical derivations of all the concepts, right? So the question is, do we actually need so many details of how things are derived mathematically, how things are formulated? So, although the things which we have been discussing in this course are very easy, isn't it? What have we studied? Simple multiplication and differentiation. Anything beyond that?
No.
Nothing. We just took simple functions, found their derivatives, solved equations and found the least square norm solutions, and found their derivatives and used the derivatives for gradient descent updates. Right? So we did not do anything very difficult. But the point is, why are we doing this? Why are we going through all this detailed mathematical explanation when all these tools are available as packages, right? We can just install a package of neural networks and just train your networks. Just like who was asking this question just now? What's your name? Abhishek was asking this question that we have, so he, for example, he wants to do some unsupervised clustering. So already he has got packages like k-means classifier or k-means clustering package already is there. He can simply use that package to do the k-means clustering. Why does he need to know what is happening behind the curtain? What are the detailed mathematical operations which are going on behind? Okay, so but my answer to him is that these mathematical concepts are first of all not very difficult to understand, and secondly, if you don't know them, you will do mistakes and you will never know how to come out of them. First of all, you won't detect those mistakes. Secondly, you won't know, even if you detect those mistakes, how to rectify them, how to come out of them. I gave you an example of overfitting, right? When you train your neural networks, so I will give you a practical example. So my students in IIT Kanpur, they are learning machine learning now. So I gave them an assignment that I gave them some data, some audio files. Let's say audio files of, in one audio file there is sitar playing, another audio file there is flute playing, another audio file guitar playing, and the task is, can you use simple neural networks to classify the audio into these categories, sitar, flute or guitar, right? Simple classification problem. So he went back to his room, he downloaded one 1 hour file of guitar, 1 hour file of sitar, 1 hour file of flute, and he chunked them into small 5-second samples. Like one sample is of 5-second audio. So how many you will get? Let us say it is 1 hour. So how many you will get?
Well, for 1 minute,
3600 divided by 5. So 720, right? 720 samples. So he got 720 samples of guitar, 720 of sitar, 720 of flute, right? He shuffled them and he took, let us say, 600 for training, 120 for testing. And he trained his model with some parameters. He did some mistakes, okay, but he was able to rectify them. And he did the classification.
All the samples were from same kind of music, so there was no variety in it.
Yeah. So he took a model, he took he trained the model and he tested on the test samples, and the accuracy was 99.99 something percent. And he was very happy that, oh, I achieved a very good classification. And then I asked him some fundamental questions. Okay, what is your training data? What is your model size? And how did you prepare your training data? He said, this is how I prepared my training data. I said, this is a mistake. You're just doing overfitting. Just now we discussed the example of overfitting. When your model is huge and the variety in the training set is small, and you just learn that variety only. A new variety will come, you will not be able to handle that. That's what he was doing. He took one file, from that file he got all his training data. If I give him another file, another flute by some other singer or some other musician, another flute recorded with some other microphone, another flute recording in some other acoustic conditions, his model will fail miserably. So what all he has done until now is just overfitting. And that is what actually happened. Means when I gave him other kind of files, performance was very bad. So that was an example of overfitting. Similarly, I was doing something similar mistake. So I was doing k-means clustering, and my data was lying on a sphere, a hypersphere. Sphere means it was spherical, means let us say, the norm of each sample is 1, right? So it lies on a hypersphere. And I did k-means clustering, found out the clusters, and performance was, okay, let's say 90%. And I was surprised, why it is just 90%? It should be better than that. And then I went back to the mathematics of it. What is happening in mathematical domain? I found out that the clustering is happening in a Euclidean space, but my data lies on a hypersphere, which is not a Euclidean space. This was the mistake. Because I knew the mathematics, so I could infer that this is a mistake. But if somebody does not know the mathematics, he will say, okay, this data is bad, so I can achieve only 90%. I cannot go higher than that. So knowing mathematics helps you there. Then I found out, okay, is there a way to do k-means clustering on a hypersphere, in a spherical space? And I found out, yes, there are methods like this. I don't have to reinvent something. Already there are methods which do this k-means clustering on a hypersphere. And when I applied those methods, the performance went up, let's say 95%, right? So knowing mathematics helps you a lot, especially, okay, those who are doing data analysis, big data, for you guys, knowing these details are very, very essential. You cannot live without these details, right? And for those who are doing machine learning, for you also this is equally important, right? Otherwise your model will be doing something garbage, or it will be performing suboptimally, means it is not performing the best, let's say 90%. And you will think, no, this is the best I can get, I cannot improve further. But if you know the mathematics, then you can see where is the mistake. Am I overfitting? Am I underfitting? Am I applying something on a wrong model on a wrong geometry? So all these things help you. That's why the mathematics, knowing this mathematics is very essential. If you would have simply used the package and you would have simply used the fit function, like in any package there is a fit function or the weight training function to train your weights, and your weights would have been something, and you will say, oh yes, I will to get it. I have to get some performance, 90% performance. But you do not know what is happening behind the curtain, that how the weights are updating using gradient descent. Okay, I will give you an example here. We discussed the gradient descent algorithm. How it functions is, oops, I don't know why. How it functions is like this. You have a slope and your ball glides down along the slope and goes to the minimum point. What if you have this? What is the best point you want to achieve? Where do you want to reach?
The lower.
This one?
This one. This one.
This is your W star. Let us say you start from here. So you will glide down by gradient descent, you will come here. Again glide down, you will come here. Again glide down, you will come here. Are you reaching the best point? You can see it now because you know the mathematics. But if you would not have known the mathematics, you will never know. You will think, oh no, this is the best point I can reach. Because you never know about this curve. You will just have a black box model, F, you feed in some x vector, you get some y vector, and you will say, oh, it is achieving 90% result, that is my model. And somebody else who knows the mathematics, he will say, oh, there's a problem here. See, my model is getting stuck in this kind of a profile. It is called a local minimum. And this is the actual global minimum. So it is getting stuck in some small local minimum. It is not reaching the global minimum. So I will use some methods to come out of this local minimum. Right? That is what the other person will do. But because you do not know these concepts, you will say, oh no, this is the best what my model can achieve. Okay. So the question is, how to come out of the local minimum now? Okay, so I'm just giving you examples that all these concepts are important. If you now, since you know the error function, the gradient descent algorithm, now you can see the problem with local minimum. And this is a big problem. This is still the current research problem, how to avoid local minima. And not just local minima, there is another problem which is even further difficult to solve. If your error profile is something like this. So what is this? Or in higher dimensions it could be a saddle point. So where your slope is apparently 0, but this is not a minimum. Just that your ball will glide down very, very slowly there. So this is another problem called saddle point. How do you avoid these problems? So you can understand these problems now because you know the concept of error function and the concept of gradient descent. Right? So further, when you will come across methods like dropouts. How many of you have heard about dropouts? How many of you have heard about dropouts in neural networks? How many of you have heard about stochastic gradient descent? So what is stochastic gradient descent?
We will put different values of the initial values of the.
Okay, so fine. What is dropout?
मीन सर जितने भी वो हिडन लेयर्स होते हैं उसको कट ऑफ कर देता है.
Good. So why do we do that?
जो मैक्सिमम वैल्यू होती है ताकि वो न्यूरॉन्स कम हो जाए.
Okay. See, if you don't know the mathematics, you will never understand the reason behind. Okay, that's why when we are studying this mathematics, do it very carefully, do your assignments very nicely. We'll discuss those solutions, those answers, what is dropout, what is how to avoid local minima. All these things we'll discuss tomorrow. Fine? But for now, do your assignments very carefully. We have posted one assignment, yesterday it was posted on, or day before yesterday it was posted, which was on estimating the weights from the given data points for a sinusoidal regression problem. Right? Today, Sachin have you posted it or do they do it? No. The sinusoidal problem with gradient descent. You have posted. You will post it, okay. Sachin will post it. So it's the same problem, but instead of using least square solution, now you use gradient descent solution. You do it and you will see the problems. I already discussed with you the problem of data normalization, how you normalize your data. Okay, so I gave that problem to some other students and they were not able to make it stable. Their algorithm was not converging at all. And I also tried, it was not converging. They had written everything perfect. Why was it not converging? Because of data normalization. They did not normalize the data. So it can lead you to serious problems. Okay. So with this background, you are very well equipped to solve that problem using gradient descent algorithm. So go back and do it. And for now, I was planning to teach further some other concepts like classification using neural networks, but there are some students who have problems with what we have discussed even until now. So I will stop here for your questions. Ask me questions about the concepts we have discussed and about the programming of these concepts. Please ask questions. You can also ask questions from the assignments which we have done, which you were supposed to submit today. What problems you face there in programming or in concepts. Don't be shy, just ask questions. Please raise your hands and ask. Okay, let us start from today's assignment. How many of you have any question in today's assignment? So some of you approached me asking that when you look at the problem, you don't know the solution, but when we discuss in the class, then you think, oh, I could have thought like that. Right? So can you now bring out those points which you would like to discuss, which will help you to better solve the assignments? Please ask questions. Don't be shy. This is the time to learn. So the more you ask questions, the more you will learn. No questions? Okay, so I will invite Sachin. Sachin can discuss neural networks, basically now the programming part. So whatever concepts we discussed since today morning, so he'll be showing a programming example of how to use it in coding. But if you have any questions, then do ask us. Ask Sachin, Keshav or myself. We are here to answer your questions.
Okay friends, everybody is now clear with what sir has taught? Back propagation and feed forward. If you are not clear, you can go through the videos, because when you are coming to class, you should first watch the videos. If you are not coming with watching the videos, you will not get anything from here. Okay, that is not very difficult to catch. So now I will explain. How many of you are acquainted with XOR gate? No one. What is XOR gate? So truth table of XOR gate. So now we will be building a machine learning model, neural networks model, to predict when I give some input of when I give my input of XOR gate, I will automatically get the output. So XOR truth table. Those who don't know what is the XOR truth table, I am just explaining it. What will be the output of this? 0 0 0 1 0. Okay. 1 0 1 1 0. So now what I am trying to do, I am trying to build a neural network model based upon this data set. This is my input data set and this is my output data set. Okay. So based upon my input data set, I am going to now build a neural network model that will predict based upon that will give the output based upon this data set. Means I will also use this data set for testing purpose only. Okay. So how will I build my model now, neural networks model? So here, how many inputs are there? For each sample, how many inputs are there? 2 inputs are there. Okay, this is my truth table. So for each inputs, there are 2. For each sample, there are 2 inputs. But sir also discuss about that. We should take bias with this. Bias, you are getting my point. What is bias? So first of all, I will explain you what is neural network. So neural network, first of all, these are my 2 inputs. This is my layer 1. Okay. Then this is my hidden layer and this is my output. Okay. So what I do, I take my input and I multiply my weights W1 W2 into these inputs, and after that I take sigmoid of this. Yes or no? For each individual hidden layer, I multiply the weights with the inputs and take the sigmoid of this. You are getting my point, everybody, those who watch the video. So I will get some output over here. This will be my V1, this will be my V2, V3 and V4. Okay. So after that, this is my hidden layer 1, and after that I will multiply it with next weights. This is, as sir explained now, Y, W, I2, I1. This is for the layer, output layer and hidden layer. And W, I1, I0, W, I1, I0. This is for the layer, for which layer? For output and hidden layer. You are getting my point. So basically what neural networks do, this is nothing. The neural networks only multiply the weights with input. After that, it gets some output. And if it is matching with my output, the desired output, it takes the error and backpropagate that error and update that weight. You are getting, everybody is clear what I am trying to do now? Okay. Akash sir? So now in my model, actually I am taking input, I am taking bias in my input. Why I am taking bias, you will get, I will also make you clear why I am taking bias. Okay, so now going to the code, I am taking my, so there are 2, for each sample there are how many inputs? 2 inputs. So now I am taking my bias also as 1 input. So you can see the layer, how structure of my layer. So this, for each sample there will be 2 data, that is 0, 0 and bias will be 1. And I will multiply my weights with the input, I will get hidden layer 1. For hidden layer, I will H1, H2, H3, H4. And after that I will take sigmoid of individual elements. Of this I will take sigmoid and I will multiply again with output layer weights. Output layer weights is W, I2, I1. I will multiply these hidden layer elements with the weights, then I will get the output. And after, based upon the output, I will get some output based upon this output, I also have my desired output. So there will be some error. What is my error function? Error function is y minus ydz minus y whole square. So I'll get some output. So first of all, I'll take random weights. I'll take random weights over here. I'll take random weights over here. I don't know what is my weight, so I'll take randomly. I'll assign some weights. And after I will multiply this 8 inputs, I'll get some hidden layer. After that, I will multiply my weights with this hidden layer elements. उसके बाद एक आउटपुट आएगा. सबको समझ में आ रहा है? ये ज़्यादा फास्ट हो रहा है. समझ में आ रहा है? ओके, फास्ट हो रहा है. ओके, ठीक है. तो बहुत स्लो बताऊंगा अभी. हिंदी, everybody is comfortable in Hindi? No. So there is one person who will require English. Okay. So I am speaking in English. So first of all, what does neural networks do? It will multiply the weights. First of all, it will randomly initialize the weights. You are getting my point? What are weights? So from weights, after randomly initializing my weights, I will multiply my weights with the inputs. Here are my randomized weights. How many number of weights are there? What is the total number of weights? Sir, now discuss that what are the number of weights. Just like if the number of elements in input are n0, and number of elements in output are n1. So what are the number of weights over here? n1 into n0. Means if I'm counting in my n0, if I'm counting my bias, so my n0 is 3, my n1 is 4. So total number of weights are here 4 into 3, 12 number of weights are there. Okay, 12 weights है. उसके बाद after that I found how many numbers of weights are there? So 1 into 4, so 4 weights are there. So initially I will take the value of weights in a random value. Okay, I will take in a random value of weights. Now after that I will multiply my weights, this weight with this individual element. I will get some h1 over here. Means let this weight be 0.001, 0.00, so something in a random value. And I will multiply with this value. I will get some after multiplying this, I will take sigmoid of that. You are getting my point? So sigmoid means what is my h1? h1 is equal to w1 into x1 plus w2. So we let me w0 w. Okay, w1, w11, w12, x2 plus w13, x3. Okay, so this will be my h1. How after getting h1, I'll get how will I get my v1? v1 is 1 sigmoid of h1. We're getting the point. Sigmoid of h1. So sigmoid of h1 means 1 by 1 plus e to the power minus s. Actually, if you go through the videos, it is very clear over there. I will only explain you now the course. Please go through the videos. It's actually very clearly explained in the videos. So I am just giving you the how everybody of you have come here to just for coding. So I will explain you how to code that, how to implement that one. Okay. So you are getting my point. So similarly, I will get my h1. From h1 I will get my v1. From h2 I will get my v2. From h3 I will get my v3, and h4 I will get my v4. After this, I will multiply my v1 with next weight, v2 with this weight, and v3 with this weight, and v4 with this weight. After that, I will get some final edge. For that edge, I will take that sigmoid of that edge, and from that edge, I will get output y. So for every input, I will be doing that one. So now what we should do? First, I will randomly initialize my weights. Randomly initialize my weight between 0 minus 0.01. Let me see what happened. So what will be my inputs? See.
हेलो
X.
सर मैं 14 ब्लॉक का बेसमेंट